For this problem, we're given some of the information about a polynomial and its zeros, and we're asked to come up with the polynomial function. So, we're looking for a fourth degree polynomial function f of x with real coefficients, and we're given three of the zeros, -1, +1, and I, and then we're given some initial condition that f of 3 is equal to 160. We'll use this condition in a few minutes. Let's start off with the zeros. We know that x is equal to -1, +1, and I, but that's only three of the four zeros. So we have to remember with complex numbers such as I that the zeros or the roots always come in what is called a complex conjugate. So if positive I is a root, then we automatically know that negative I is a root as well. So now we have our four roots, and we'll write them in factored form. We'll write f of x is equal to, now I'm going to put a in front of the factored form because I don't know what this leading coefficient is going to be until I use this condition f of 3 is equal to 160 in just a few minutes. So let's start off with a, and now I'm going to write x minus my first root, which is -1, times x minus my second root, which is 1, times x minus my third root, which is I, times x minus my fourth root, which is -I. Let's do some simplifying. We get a times the quantity x plus 1 times the quantity x minus 1 times x minus I times x plus I. Now, when we simplify this, let's multiply out the x plus 1 times x minus 1 first, and we'll also multiply out the x minus I times the x plus I. So we'll have a times, well, if we multiply x plus 1 times x minus 1, that just becomes x squared minus 1 because our outside terms and our inside terms cancel. For x minus I times x plus I, we'll have x squared. Notice the outside terms we get plus x times I, and for the inside terms we get minus x times I. So they add to 0. And then the last two terms, we have a negative times a positive, which is a negative, and I times I is I squared. But we need to substitute -1 in for I squared. So we have a times x squared minus 1 times x squared minus -1, which is just a times x squared minus 1 times x squared plus 1. And we can multiply that out, and we'll get a times the quantity x to the fourth. Notice again my outside terms are plus x squared, my inside terms are minus x squared, so they add to 0, and my last two terms are minus 1. So we have a polynomial. It is f of x is equal to a times the quantity x to the fourth minus 1. Now we use the initial condition up here. We see that f of 3 is equal to 160. That simply means when x is equal to 3, the function value or the y value is equal to 160. This is a point on our polynomial. So since f of 3 is equal to 160, I'll put 160 in here for my y value or my f of x equals a times, I'll substitute 3 in here for my x, 3 to the fourth minus 1. Now I can solve for a. I get 160 equals a times, well, we have 3 to the fourth, which is just 81, minus 1, which is just 80. If I divide both sides by 80, I get that a is equal to 2. Now I'm ready to state my final answer to my problem. I'm looking for the polynomial function. So the function is, I'll write it up here in blue, f of x is equal to a, which we just found out is 2, times the quantity x to the fourth minus 1. And I could if I'd like to go ahead and distribute the 2 through, and I'll write this one more time in red. I could write that final answer as f of x equals 2x to the 4th power minus 2.